Question 13 provides you with some really nice summary points. You'll have graphs that only have one x-intercept, the point of inflection, graphs that will have a double zero, a single zero, and a graph that will have 3 zeros, and one that you're going to have to fiddle around a little bit with first. Now, in the first instance, this is a classic point of inflection case. It's in the form a lots of x minus h cubed plus k. So point of inflection will be -3, 0. The y-intercept, well, that's going to occur when x is equal to 0. In other words, 0, 27. The x-intercept, well, we've got a triple there, -3, 0. So all that remains is for me to sketch that up. Like so. In B, we're looking at a case of having a double zero and then a single zero. Now, these can sometimes take a bit more observation, so we won't have a point of inflection. So my y-intercept in this case, when x is equal to 0, so that's going to be -9 or 0, -9. X-intercepts occur when y is equal to 0. -3 as a double and +1/2 as a single. Now, I've pretty much got everything I require in order to sketch the graph for that. Oh, forgot to mention the shape. We're coming from the negative, negative, ending up in the positive, positive. Something along the following lines will be the order of the day for our graph there. Now 13C is of the format where you're going to have 3 zeros. First thing I'll figure out is my y-intercept, and that's when x is equal to 0. So in this instance, it's going to be -15 or 0, -15 for my y-intercept. My zeros or x-intercepts, reading straight off the information above, x is equal to -3, 1/2, or 5. The overall shape is going to be something looking a little like that. So I've now got the information in order to sketch my graph. It's probably looking something of this particular order. So a neat little question that. You've now had a bit of a practice at a point of inflection type, a double zero case, and then a 3 zero case. Problems that are all fair game for formal assessment. Working through 13D is a little trickier because I have to work out what y is first. And dividing through, I can find my expression in order to commence the problem. Now I'm not going to sketch that, but you can see that the point of inflection is going to be at a half, 1. Forgot to divide that through by 2. And the y-intercept when x is equal to 1, x is equal to 0, sorry. It's going to give us 2. And to find the zeros, so I've just realised I made a little error. That, of course, should be 3 over 2 for that to work. Now, to find the zeros, that's what happens when y is equal to 0. I end up with 1 minus 2x cubed plus 1 is equaling 0. I'll just have to continue that on the next page. And that, of course, was 1 minus 2x cubed is equal to negative 2. I now take the cube root of both sides. And that will give me, I better just quickly work the cube root on the calculator. And that will give me negative 1.26. 1 minus 2x is equal to negative 1.26. And 1.13 or thereabouts. And that gives you the okay to go ahead now and plot the graph.